Okay, so here is class 3. I guess I'm feeling ambitious, and I'm going to go through at least some of it. Maybe you could tell by my shirt it's the same. It's the same evening. So we're going to combine the stresses. So this is class 3 of ME370. In class 1 we reviewed statics. Class 2, we reviewed the basics of mechanics and materials, different kinds of stresses. Now we're going to review and combine the stresses and then find the principal stresses, which is also known as Moore's circle. So in this first video, I'm just going to go through an example. Again, it's going to be the door handle example, but I'm going to do it for a different point onto the thing, right? So here we go. The combining stresses onto the stress element. One of the most important skills. So we did, we found the basic stresses for A. We're going to use a B on this same guy. So let's just assume that we have the results of doing the statics on this piece. Remember, this was the door handle, and it was loaded with 1500 being pulled right here, right? So let me see if I can make this a little higher right here. So we had a force of 1500 pulling onto this, right? We also had 800 going downwards, right, onto there. So going downwards to try and, that's like the action that was trying to turn the handle. We also had 1,000 pounds that was trying to push right in there, right? So it has some total vector that would be kind of going down and away onto the thing. I guess like sort of like that right over there. But these are the results as transferred over to here. We found the reactions on the free body diagram in class 1. Then we said put them over onto the stump for the equivalent forces and moments, and here they are summarized. So now we want to see what's happening to point B that's like right there, right? So on this guy, let's see, I could put a fresh eraser in there, right? It's a pretty tight fit right in there, right? I think I chopped the last one apart. Whoop. Yeah, it's too tight of a fit. There you go. Ugh. You could turn the video off and put the thing in, or you could just go live struggling with it. Okay, so anyway, we're going to have an axial that's going to pull it. We're going to have a bending that's going to either squash it or stretch it. We're going to have a torsion that's going to try to twist it, and we might even have, we can see we have a transverse that's going to try to chop it apart too, right? So let's take a look. One of the very first things that we almost always do in any of these problems, and let me let me get out my notes so I can, because I already did it, one time, so why would I do it again? One of the very first things we do in lots of problems is figure out what the section properties are. That's a good test-taking strategy. Get stuff out of the way. So A, the area of the cross-section is pi over 4 d squared. It's a 1-inch section, so it's not an exciting thing. 0.7854 inches squared. I of the thing, it's symmetric, so it could be either about that axis or that axis, it doesn't matter, is pi over 64 d fourthed, and that's going to be 4.909 e minus 2 inches fourthed, right? And then we have J. It's actually just going to be 2 times this. That's a good shortcut, or pi over 32 d fourthed, and that comes up to 9.817 e minus 2 inches fourthed, right? So one good step right from the beginning, maybe we'll do that just as a test-taking strategy, get that out of the way just to get some motion to get things going, right? And now we want to go, let's say that we did all the statics and we figured out what all these reactions are. We want to start going down the list of stresses. And so it's a nice list to just keep going. Axial. The axial is F over A. But which F? Well, it's 1,500. This guy, right? He's aligned with the axis. He's the axial force. 1,500 divided by the area, 0.7854. We get 1,910 psi. And I should stay away from this. I should try to leave some room for my stress element. And it's pulling away from the thing. So it's causing tension. And it doesn't matter whether it was A or B onto the thing. Let's see, focus. It's pulling away from it. So it didn't matter if it was A or B. It's a uniform distribution. That's why we talked about uniform distribution. So it's in tension. Doesn't matter. It's got the same value at A and at B. We're looking at B right now, for B right now. I'm going to move this down and write for bending. What do we have? Well, hopefully we will memorize it's MC over I is the correct equation for bending stress. And the big question, here's the thing you're going to be tested on. Which of these moments causes bending at B? Right? Is it 2,400 inch-pounds? That's going to be about the z-axis. Is it 4,000 inch-pounds about the x-axis? Or is it 4,500 inch-pounds about the y-axis? And the answer is 4,500 inch-pounds about the y-axis. And how did you know? Well, you observe this, right? Going about, whoops, I think I have this wrong. There you go. About the y-axis, which is vertical here, is going to cause this to want to move, right? It's going to cause, let's see, yep, and it's going about this way, right here. Going about that way. So it's going to try to pull on B. It's going to push onto the guy that's opposite of B, but it's going to try to pull. So it's going to cause tension at B. So, whereas this guy right here is going about the Z, is going to pull on A and push on the guy opposite of A, but B is on the neutral axis of what takes place in the 2,400. So this one is 4,500. C, remember, is 1/2 of the width of the. Right, so it's just going to be the radius in this case of 0.5. I 4.909. E minus 2. And so we get 45,830 psi. And as we mentioned, looking at our part right here and looking at the load that's being placed on here, that causes tension, right? Because it is circling around that way, right? So that's tension. And now we have, when I have shear, going down the list, we have torsion. Tau torque is going to be TR over J. Now that's going to be the same as we had in the previous example right there, right? It's that 4,000 is causing a torque. And R is 0.5. And J is going to be 9.817. And that's going to give us 20,370 psi. It's not tension or compression. No. Tension and compression only apply to normal stresses, which are axial and bending. Shear, we're just going to have to wait a little bit before we make a decision on what direction we want to assign it when we go to combine it. Assign it when we go to combine it. Kind of rhymes. And then we have transverse. Transverse, for a circle, is 4/3 V over A. You can look it up. 4/3, but which V? Which V is causing transverse at B? Remember that it's got to be the one that has the stress element to the side of it, not the one where it's running through. You'll see that the 1000 is running through B. It doesn't cause any transverse shear. The 800 is running here, and B is to the side of it. So it's the 800 right there. So 800, and it's just the area like we had before, 0.7854. So we get a 1,358 psi. Now we go to combine these together. So sometimes what I will do is I will write out a stress element over to the side. All right, so I already did this for you, but you need to look and see that B is in the, if that's the X and that's the Y, and let's say that's the Z, that B is in the, and I wrote that wrong, didn't I? Yep, I wrote that wrong. This should be the XY, right? So that should be the X and Y. Whoops. How many times am I going to get it wrong? I don't know. But you can see that B is in the XY, or parallel to the XY plane, right? So that's the one that we're going to label there. We can see that for the axial, we have, and I should have made some more room over here. Let me make some more room over here. The axial right there is going that way, and the bending is going this way because they're both in tension. So they're going to add together. That's not always going to be the case. Like for instance, if we picked the spot that was over here, right? So here's B, right here is over on that side, but that's going to be tension over on this side, but compression. So the bending would have been over here, compression, so we might think of that as being negative, but the axial is still in tension. So they're actually going to counteract each other, right? The whole idea when we're combining stresses is the idea of superposition, that we take these individual things that are happening to this piece and we combine them together, we add them together, right? So it just happens to be the case that these are both in tension. So now we take a look at the torsion. What happens to B? It's good to come back to this figure and think about what that thing is doing. It's coming around and it's coming down the face that's exposed to B. Because it's good to, let me see, I'll write it out as a separate thing. It's maybe good to write this as a bigger thing right here. Like here's the axes right here. And here is the stress element of B. Let's see, let's actually make this in the right spot right there. Okay, so we kind of, here's our axes right here. So here is B right there. But it's also, because it's a cube, has a face right there. So when we go to see that stress element, we're looking at this part of it, but it's this face, like right along there, that we're going to be thinking about what's happening with the shear that's taking place on the thing. Well, the torsion that's coming around and happening on the face is coming downwards onto that face. So it's down like that. We also have this 800 pounds, that too is going down. So that too is coming down onto the face. So what I'll often do is maybe I'll go like that and that right there. If I'm trying to, work it out, or I'm trying to like explain it to a student, we don't have to do that every time. But if you're confused about the thing and you need to talk it out to yourself to try to see which direction it's going to go, it's good to make a side one like this. And then when you're done with it, you could say, okay, well, here is what the results are going to be, right? We'll have our sigma right there, and this tau is going to be right there, right? So this is going to be tau xy. This is an XY plane. And once you know one of these, once again, right, you're going to go up in that direction, and that direction, and that direction, right? These arrows always point towards each other to be able to be balanced out, right? So we've labeled this up here. Let's go back down here and find out what these values are going to be. So we say that this sigma x is going to be, and let's turn it into KSI, right? Because these are really long right here. And they're both tension. So we're going to say that that's going to be 1.910 plus 45.83. So we end up with 47.74 KSI and label it as tension. Although if we were to put this right here and with this drawing is already kind of telling us that it's tension, but it's good practice to tell people. Don't use plus and minus, use T and C, right? And don't use arrows, use T and C for here, right? And then tau xy is going to be 20.37 plus 1.358. So we get 21.73 KSI, and we don't go tension or compression. We don't do any arrows. We let the stress element tell us. So a lot of times what we'll do is we'll just put the value. Like instead of putting that sigma x here, I'll just put 47.74 KSI. I don't put tension there because I have an arrow. It'd be redundant. And then I put 21.73 right here in the upper corner, right? So there's like a full problem done as an example for combining stresses. I kind of think maybe I should have done done problems where where they don't agree with each other, and we will do some problems where they don't agree with each other. But be on the lookout that the most important things that I stress, no pun intended. Number one, get me the correct moment that causes bending for the location that I want. And this is for B, right? Like right B right here. B, they're 4,500. If you use 2,400, that's a sign that you don't understand what's taking place. And it's got to be big points. Not a penalty. It's just measuring your mastery of the thing. It demonstrates that you don't understand what's going on. If you give me the wrong force for the transverse, right? If you use 1,000 for when it's going to point B, you don't understand the orientation and the cause and effect, right? So it isn't about equations and numbers. Yes, these are easy equations to pick out. And if you get the wrong number, it shows a misunderstanding of what's taking place. If you give me compression when it's tension, if you give me the wrong direction of the shears, whether they're combined or wrong, those are concept errors and they're big points. Even if you get these individual numbers correct, those are just plugging and chugging. It's the signs that are really important, and the sense of them, right? I say signs, but I mean the direction of them and whether they agree or disagree, right? Whether they're combining together or they're counteracting each other. These are very important things. So be on the lookout for that. This will come up again and again. If you're feeling queasy about which way this goes, please come to me and we'll work through problems. We'll work problems together until you can get it straightened out. It isn't necessarily an easy thing. People very much struggle with combined stress problems. So we're going to do a lot more of them. So just be ready, but don't be afraid. We're going to get this straight in your head. Thank you.